Hello, my name is Alec. I'm the Technical Manager at Quelfire, and this is the second part of our MEP Considerations. We did originally just plan to do this as one video, but we started talking and it's such a big subject that we've now put together this second part. So let's move right into it. Sprinkler systems are very common in buildings now. One of the materials that are used are what's known as CPVC. So that's this orange pipework that you see behind me. Now, CPVC pipes are a great system. It obviously has a lot of benefits, especially from cost compared to steel. However, it does have some concerns, and one of those concerns is what's known as chemical compatibility. So you need to ensure, because of these pipes are under a lot of pressure from the system that they're performing, that the solution that's being used around them is compatible to not damage the pipework. So our Quelstop HPE sealant, for example here, has been approved by both Lubrizol and Spears for a large number of years. Actually, before I even joined Quelfire, we have been on their approved register. So we have solutions where you can have the HPE sealant directly to the CPVC pipe. However, obviously, depending on where you are in certain locations, if you're going to have a lot of services close together, you may be worried about the install of anything dropping onto the pipe itself. So we do have solutions such as here, where you could include an extra sleeve just to protect that pipework from anything dropping onto it, and we have a solution for that. We also, for Lubrizol CPVC pipework, have had our QIF fire sleeve approved, and this can be extended if you need to. So this is a foil-faced sort of mineral wool with intumescent embedded inside it that is approved. So that just goes around the pipe, similar to pipe lagging, and just goes right through the penetration. But it's very important that you check what products are approved. Both Lubrizol and Spears have chemical compatibility registers. If you need any more information on these registers, go to our Knowledge Hub. We have a dedicated section on CPVC, and that will give you all the information. So now the next consideration we're going to look at is what's known as sleeving of pipework. For many, many years, MEPs have used what's known as sleeves to help feed their pipework through. And I understand this makes it much easier for you. So you could have a pipe inside of a pipe, cables inside a conduit, etc. like this, again, like pipe through pipe. However, it is important that what application you're using, there is a tested solution. And more often than not, sleeving of certain pipework is not actually tested. Or where it has been tested, for example, we've done some testing of a copper pipe inside a copper pipe. It is limited only to integrity only. That means it will stop the fire from getting from one side to the other, but it doesn't stop that heat transfer. So if your requirement is both integrity and insulation for the fire resistance, that application won't be appropriate. A very common one is what's known as gas pipes, and I'm going to talk about that in the next consideration point. On a lot of projects, there are going to be gas pipes, and they have their own rules which are set out in the gas regulations. One of those factors is about sleeving. So this isn't just about fire here. There is a requirement in the standard to have a sleeve through walls and floors. So we have done some testing on certain systems such as track pipe, gas flex, GFS. And as you can see here, with the metal pipe, we've actually used a plastic sleeve. The reason why they've done this is, one, the manufacturers of these systems advised us this is what they advise to use. And also, from a fire resistance perspective, again, this is where reaction to fire and resistance to fire can get confused. We actually get a better performance sleeving these metal pipes in a plastic sleeve than we would, say, if we sleeved them in a metal sleeve. So again, that is something to consider, because this plastic sleeve will melt away. There'll be no way for that heat to travel through the penetration, and thus we can get a much higher insulation fire resistance factor. So again, when you're considering what services to use, it's good to have a look at what's available. So again, in an early engagement conversation with Quelfire, we could advise these are the sleeve gas pipe solutions we've got that may meet your requirement. And we have the same thing for both walls and floors. Again, as I mentioned earlier, we have specific testing that we've done for certain spacing, so you can have them in clusters if it's practical to install, and we can advise further. One of the things to note that's slightly different with some of the solutions here is you'll notice that there's a small gap around the pipe with the sleeve here. This is sealed on one side only with Quelstop acrylic sealant. That's the white sealant that you see in between the conduit and the cables here. And the reason why it's sealed on one side only, again, meets that gas reg. So it offers that cold smoke protection, but it does leave one end open to meet what the gas regs has the sleeve there for any ventilation and stuff like that as well. So the consideration I wanted to let MEPs know is about plastic ducts. There's a lot of confusion in the industry about duct work. A lot of the guidance that's put out there, especially in approved document B, for example, is more in relation to metal ducts and metal dampers, for example. But obviously plastic ducts are used quite heavily on projects nowadays. Plastic ducts are typically tested to BSEN 1366 Part 3. That's the test standard for service penetrations. So that means it's tested in the same way as a plastic pipe. There are a few other things we have to do, such as capping, but I don't want to go into that. But the main thing here for the MEP designers is that these can actually share the same aperture as other service types, as you can see here. So this is great when you're looking at sort of spacing and considerations. However, on the next consideration, you see why I brought this up, is we're going to have a quick discussion about metal ducts. So whereas plastic ducts are tested to BSEN 1366 Part 3, metal ducts have their own set of standards. They actually have quite a few different ones, depending on their application. So because they're tested to things such as Part 1 or Part 2, or there are a number of different ones, they should not share the same opening as other service types. So very often you'll see that the MEPs will run cables with metal dampers, etc., and this is not allowed through fire separating elements. There is a manner of possibly in the future of a way of testing that. It has been released, but because the test standards are so drastically different, it is quite hard to actually accommodate that. When you're looking at metal ducts and dampers, it is vital, again, at early engagement, to speak to those manufacturers, make sure you're following their guidance and you meet all the requirements they have as well for that. So just remember, plastic can go in the same, metal can't. The next consideration I just wanted to talk about is cable carriers being used for other service types. So earlier on I talked about spacing of services, and one of the two caveats I mentioned were services of the same type, so where I said, say, 2 cable trays, and services of a different type. So you can just see here we've got some insulated copper pipe in Armaflex and cables here. However, we were aware that in some scenarios there are often air conditioning units that have these type of pipes with this insulation and cables together, or these are positioned on cable carriers. Now again, this is a great solution for MEPs, but they need to make sure that they're using an appropriate detail. So for example, yes, we have a solution with this pipe work, with this Armaflex on a cable tray going through a wall, but the fire resistance rating, especially again from that heat transfer perspective, is very low. So whereas you can stop the fire maybe for 2 hours, you can actually only stop the heat for 20 minutes. So if you've got a requirement of 60 minutes or more, then that solution isn't suitable. So there we would advise stopping and starting the cable carrier, or alternatively, this goes back to my earlier video, you could use a cable basket. So we do actually have a solution for a cable basket with this type of pipe work that can get up to 90 minutes. What we also did, because we were asked to try and accommodate this, is on that application with the basket, we can actually have cables and insulated metal pipes mixed together. So that's looking at something that Quelfire have looked at. What does the industry need? And we went away and tested that specifically. So that one is just to show, tell you that you can have carriers for these type of pipes. However, it's best to check. So reach out and I'll show you the information. So we've covered sort of cable carriers, cables, that now. One of the things I wanted to talk about is, especially for MEPs, is what do you do with pipe joints or bends? So let's talk about that. So very often it's much easier for when you're running your MEP routes that the pipes might bend directly after a wall or directly after a floor. And again, this might be easier for your service runs, but it might not be easier for a fire test solution. So again, you need to check before it's installed that there is an appropriate solution, especially when you were talking about coming through floors, because there's not always a solution for that. But an example where you can sometimes have a solution, but again, it comes down to the application, is stuff like this. We wouldn't recommend it. It's more ideal to have the pipe come out at the correct angle, but there are possible solutions such as the one here. So again, this is where the early engagement comes into play, is yep, run it, but this is the areas that you'll need to discuss with all parties, not just us, there might be concerns from the wall or there's doors, other factors. We need to look at this as a group and make sure that we're using an appropriate detail. So the next consideration we're going to be looking at is what is known as partial penetrations. So there is something what's known as partial penetrations. And what I mean by that is some services just go through one side of the wall, then drop down the cavity, for example, conduits to socket boxes, pipes to radiators, that type of thing, where they're only penetrating one side. Unfortunately, at the moment, there isn't an official test standard for partial penetration. So for manufacturers such as Quelfire, we try and test to the most appropriate standards. So the BSEN 1366 Part 3 is the service penetration test for full penetrations. It's reasonable to use this for partial penetrations. And we do have some solutions. But again, it's vital that you incorporate our design. So very often, for example, conduits, it's very easy for MEPs to have them at 45-degree angles, the dry liner to put the wall up with a nice cut U shape in the wall, etc. And that's very efficient for both the MEP and the dry liner. However, when the fire stopper comes along, the solution that they might need to use might not work. So again, it needs to incorporate a solution that all trades can work to. So again, reach out to us because we do have a number of different solutions for partial penetrations, such as conduits, or we can talk through them more, just ensuring that you're installing it in a way that a tested solution can be used. So the next consideration that we're going to look at as we're talking about partial penetrations is socket boxes. A very often overlooked penetration are socket boxes in walls. You can have metal, as you can see here, plastic, etc. And again, they are going to need a tested solution. So it's vital that, again, when the MEPs are looking at selecting the socket types, that they're picking one that are appropriate. So, prime example, where you might want two socket boxes close together, for example, a kitchen, it is vital that you would use a metal socket box because we have test evidence for a gap of 20 mil, whereas if you use plastic, you need to have a space of 100 mil. That goes back to our first sort of area where we're talking about spacing. So again, that's a consideration. Plastic might be more ideal for you, but the spacing doesn't work, so you'd have to use metal. And again, it comes down to the installation of the actual socket. So like what Quelfire did, because we got feedback from sites, is we've tested the socket box sat behind the plasterboard, because very often they get fixed first, then the dry lining goes up. And we have solutions where you can bring the putty pad to the front edge, as you can see here, for example. And we have other solutions for media panels, things like that. So when we're talking about socket boxes, again, reach out, speak to us, tell us what you need, and we can advise accordingly. So the next consideration I want to discuss is services going through linear gaps. So in buildings, there are going to be gaps, say, for example, on the head of the wall, or here, when we're talking about profile deck, that's known as the linear gap or cavity, etc. And it's very, common to see that the MEPs will see those gaps and go, oh, I can put my services through there. So, for example, here, where we had the profile deck hole, it's very common to see services go through there. Unfortunately, this is an area that's not really tested. Linear gaps are tested to Part 4 of the BSEN 1366 standards, whereas services are tested to Part 3. And because they are slightly different test standards, they're tested separately. So where you want to have solutions, again, check that this is tested, or ideally you'd have solutions lower down, going through the wall, and then using an appropriate sealing method. So because we're looking at linear gaps, we're also going to look at considerations when services are going through deflection zones. So where we've just talked about services going through the linear gap up there, on a lot of projects you're going to have the deflection zone. So on top of the plasterboard wall, for example, you typically have an area that's been designated for building movement. Again, very often we'll see services get tight to the soffit and going through these penetrations. So here, for example, we have a product where we have a head of wall application. So there's services very close to the wall, but often you'd have the services tight to the soffit. And unfortunately, you can't have them running through the deflection zone. To be honest, it defeats the purpose. If there's movement, it's going to damage the services. So again, the services need to be positioned ideally in the right location. Now, again, what we did understand is there are certain times that certain services get installed very earlier on. So when we looked at the plastic ducts, so we're just going to move slightly over here so you can see them again, the plastic ductwork, for example, very often these are installed long before the walls are put up. So these are often fixed tight to the soffit with our QRS fire sleeve already installed. So we understood that requirement. So we do have a solution specific for plastic ducts, just on these on their own, where you can build a very tight three-sided letterbox that incorporates the QI Intrafoam product that we just looked at underneath the QRS, that can allow that sort of deflection zone to be below the ductwork, not above it. It's only for these type of services, and again, reach out to the technical team that we can discuss with you. But ideally, for most all the other service types, you want to be ensuring that they're low enough down that they're not affecting the deflection requirements in that project. So that was just a few considerations that we had about service types for MEPs. Obviously, it's a lot to take in here, and I'm more than happy to discuss this with you if you need to. I work on a lot of projects with the early engagement, usually getting brought in now at REBA stage 3 when the MEPs are starting to run those routes, beginning of REBA stage 4. Please get in touch with me. I'm happy to support you. I'm able to share the golden rules I mentioned earlier about how to run the services, especially for builders working connection openings. I can help discuss any of the parts of BSEN 366 Part 3 that I mentioned, or just if you want the find out what tested solutions we've got, or possibly let us know what we need to try and hopefully test in the future. Reach out, the contact details are on the screen, and that's all from me.